Thank you, Airwick, for having me for the second time in this great venue. As I mentioned, I'm the Cloud and AI Security Group Lead. So prior to deep dive into the cyber AI coexistence cycle, I would like to quickly introduce our group. So our group deals with emerging unsolved cyber challenges using AI capabilities in various domains. On your left, you may see some examples of our work. So from top to bottom, we have AI-powered behavior-based ransomware protection on cloud endpoints. We have automating DDoS attack detection and mitigation using AI on web application firewalls. And we also have digital object sensitivity classification using language models. So our research is not limited to these domains. It also includes other domains such as CDN security, IoT security, AI model protection, application security, and more. The group's research is production-oriented. That means that from our point of view, a successful research is when our core technologies are eventually implemented in Huawei's cloud. In addition, the group has several collaborations with leading universities. We are also writing different academic papers, and we are publishing patents in various domains. So now, after this short introduction of my research group, we may advance to the cyber AI coexistence cycle. So this talk will give a high-level overview of the cyber AI coexistence cycle that presents the three types of relations between cybersecurity and artificial intelligence. So the first and most known is the usage of AI to enhance cybersecurity. The second is how to protect AI-powered systems and the machine learning pipeline. And lastly, I'll present the still far-fetched concept of cyber AI and how should we approach it defense-wise. So we start with the first relation, how AI is used to enhance cyber defense. In recent years, we have seen significant advancements in both cyber offense and defense. And this hexagon helps to emphasize the evolution that we have been seeing. So cyber defense is now the concern of every C-level executive. We see that the volume, the variety, and the velocity of cyber attack increases unusually fast. And accordingly, organizations are required to change the cyber defense nature from reactive to proactive. They're obligated to improve their performance. They are required addressing new demands and capabilities. And while doing so, they're also required reducing the costs of the ever-growing stack of tools and manpower that are required for these tasks. So for all of these reasons, in recent years, AI has become the backbone of cyber defense technologies. Now, according to the maturity model of Gartner, we see that AI was significantly incorporated for cyber defense, but still, there is much left to be done. And more specifically, we are now at the stage where almost any cyber defense platform holds at least one AI-powered service. But when looking ahead, these platforms will be mostly AI-powered. These puzzle pieces give a glimpse on different AI to enhance cyber defense usages. For example, in the identity and access management domain, we incorporate AI for biometric authentication. In the application security and in the development lifecycle domains, we incorporate AI for dynamic application security testing. In the web security domain, we incorporate AI to differentiate between bots and people. And in the data protection domain, we incorporate AI to create synthetic training data to prevent sensitive data leakage. Now, business-wise, there are hundreds of cybersecurity companies in Israel. According to Startups Nation Finder, during 2021, $6.3 billion were invested in Israeli cybersecurity companies. The interesting thing is that more than 95% of these startups incorporate AI-powered capabilities as part of their core technologies. So the second relation between cyber and AI is protecting AI-powered systems. But before we advance to explaining how protection takes place, we must understand adversarial machine learning, which means exploiting vulnerabilities in the machine learning pipeline to manipulate AI systems such that their behavior is changed to serve some malicious goal. So the ML pipeline includes 4 stages. We have the data collection or data creation, we have the training process, we have model extraction, and eventually we have the deployment in production environment. Now, all of these 4 stages are divided into 2 sections, the training phase and the inference phase. But from adversaries' perspective, the convention is that adversarial ML includes 3 types of attacks. The first is the training time attack, where the attacker exploits the fact he has control over training data or over the training process. The second type is an attack on edge or on the client, where the attacker exploits the fact he has access to the deployed model on the edge. And lastly, we have the inference attack, where the attacker finds exploits by querying the model as a black box. So let us review some examples to better understand the 3 types of adversarial attacks. So the first is a training time attack, or more specifically, a poisoning attack that was conducted on Tay. Tay is Microsoft's Twitter bot that was developed to entertain 18 to 24-year-old Twitter users with casual conversations. So a poisoning attack conducted on Tay when its model was fine-tuned by interacting with real Twitter users. So the adversaries exploited this feedback loop by repeatedly using racist and offensive language when interacting with Tay. After less than 24 hours, they were able to bias Tay's dataset towards that language. And Tay's conversation algorithm began generating inappropriate language. This attack led to the removal of Tay after 24 hours, and later that day, Microsoft shared an apologies announcement accompanied with an explanation about the poisoning attack. The second example is an attack on edge, where the adversary has access to the model, or at least partial access to the model. In this example, Fredrickson et al. Presented an inversion attack that uses the confidence values of a facial recognition neural network algorithm to recover recognizable images of people's faces, given only their names. Now, they raised a serious privacy concern when the research was implemented on an ML as a service known platform. Lastly, we have the third example, which is an inference attack. Specifically, this one is called split-second phantom attack that was presented by Nasi et al. So the attack includes projection of 2-dimensional objects such as signs or people on roads, on trees, or on billboards for a split second. This made commercial advanced driver assistance systems such as Tesla and Mobileye to apply wrong and in some cases dangerous actions such as stopping the car or issuing false notifications to the driver. So the range of attacks is significantly large and includes tens of attacks. Most of these are still academic in nature, but as experience taught us, they are soon to become more noticeable. Now, to explain where we stand in the context of adversarial ML, I will present 3 pieces of information that will help to better orient in this landscape. So the first is the fact that many leading and known companies already have prior experience with adversarial ML. Some attacks were in the form of research and some in the form of actual production attacks. In practice, this caused a significant damage to these companies, mostly with the fact that trust in the machine learning services decreased significantly. The second is 2 reports that were presented by Gartner and by Microsoft. So according to Gartner's review, by the end of 2022, 30% of cyber attacks will involve adversarial ML. According to Microsoft research, 90% of organizations don't know how to secure their ML. The conclusion is that currently industry is simply underprepared for adversarial machine learning attacks. And lastly, an interesting partnership of industry and academic research group have gathered to address the adversarial ML problem, which resulted with the adversarial ML threat matrix. This is the first attempt of crowdsourcing and mapping of adversarial techniques against ML systems. So now, after reviewing adversarial ML, we advance to ML pipeline protection. So the first ML protection method modifies the model such that it is more robust for input triggers that cause it to infer an incorrect response. We do it by generating adversarial examples that can fool our model and add them to our training set. On your left, there are two examples of how to generate adversarial samples. The first is using domain-specific adversarial sample generators. Most of these are open source that were developed by some of the leading companies and research institutes in the world. And the second example is training a generative adversarial network in parallel to model training, such that the generator is capable of creating adversarial samples which may fool the original model. So on the right, we have the second method, which is model monitoring. So we use feedback loops to decide when model update is required. We do so by creating a framework that monitors the model using different matrices. And in general, there are three commonly used matrices for model monitoring. The first is performance metrics that monitors the classification or prediction performance of the model post-deployment. The second is stability metrics that captures data distribution shifts of the model attributes. And the last one is the operational metrics that simply monitors the operational system health. So now we advance to the last and third relation between cyber and AI, which is protecting cyber AI. So there are three categories of cyber AI. The first one is using adversarial ML on AI-powered cyber defense systems. The second is using AI as a tool to improve traditional cyber attacks. And the third one, which is the most controversial, is creating synthetic adversarial data. And at this point of time, it is mostly used to generate synthetic fake or malicious media. So as you have already got used to, there will be three examples, one for each of the cyber AI methods. So the first one is an adversarial ML poisoning attack on an AI-powered antivirus. The adversary's goal was decreasing the revenue of a software company whose product is a rich client application. So for the purpose of privacy, I'll not be telling the name of the company. Let's call it Questionmark. So the adversary reduced Questionmark's revenue by preventing its application from being executed on PCs who used commercial antiviruses. They did it by creating samples that combine code from known malwares and from Questionmark's application. These new files were uploaded to VirusTotal, the threat intelligence platform that serves as a malware sample corpus for many antivirus vendors. And these new files were incorrectly classified as malicious by VirusTotal, and accordingly, the antivirus vendors had labeled misclassification poisoning when updating their model with new malicious samples from VirusTotal. And eventually, this led to an antivirus AI model misclassification and eventually execution prevention when encountering Questionmark's application. The second example was conducted by ZeroFox. They presented how to improve social engineering attacks, or more specifically, targeted attacks in social media by learning the attacked object's properties such that the model produces specific phishing tweets or messages that increase the chance of the attacked object to click the malicious link. And lastly, we have created a synthetic adversarial media in the form of deepfake video that includes both video and audio casting. So let's hear what our dear friend Bill Gates had to say when asked about the AI Week conference. Uri, if I have any issues with the voice, please let me know.
Can't hear you. Can't hear the voice.
Just a second. You simply must see it. Can you see my screen now?
Yes.
Hey guys, I was really looking forward to attending this conference, and specifically this talk. Unfortunately, the conference went virtual. I am so disappointed. Therefore, I decided to compensate all audience watching the current talk with $100. To receive the payment, simply click on this link, and the money will be transferred within 24 hours.
So whoever wishes, you may transfer money. But this video is an example of a phishing attack that eventually may be the future of cyber AI. And for now, we see a significant increase in synthetic media cyber AI attacks in various forms. We've seen stealing money from bank accounts using AI-powered robocalling. We've seen how to create fake news or content using advanced language models. And we've, of course, seen deepfake videos of known personalities and putting words in their mouth. So this should be a major concern for all of us, both cyber defenders and machine learning experts. Regarding the question, how to protect from cyber AI, I'm afraid I'm not bringing any good news. Currently, governments are trying to dictate laws, ethical rules, and principles on fair and safe usage of AI, but unfortunately, that will not solve the problem. From my point of view, we are soon to reach the era of AI war, where adversarial AI will challenge and compete the defensive AI. And I believe that the domain of protection from cyber AI will soon become a leading research domain for both academy and industry. To conclude, the cyber AI coexistence cycle is large and complicated. We've seen significant advancements in both adversarial and defensive sides in recent years. Currently, most of our focus is concentrated in how to improve cyber defense using AI, but soon the hazards of adversarial ML and cyber AI will be simply impossible to ignore. My goal presenting this talk is to convey leading companies and enthusiastic researchers from both academy and industry to start addressing these challenges before they will become too much of a challenge for us. And before I finish, I would like to describe a reality that might seem far-fetched, but actually exists in real world. Imagine an AI judge that gives a verdict in the court of law, or a metaverse that replaces you or your colleague when playing poker in your virtual world. And lastly, imagine an AI-powered doctor that gives diagnosis and decides what treatment you should take. From my point of view, this is scary. That's it. Thank you.
Thank you very much, Yoni. It was fascinating. I think you covered everything with AI and cyber altogether, and we're expecting a very challenging future, I think, both as users, but also as scientists and people that are accountable to solve those problems. Jumping straightforward to two questions raised. One of them, you were talking about your research in the domain of the AI enhanced cybersecurity defense. Is there any research in your group, in your experience, conducts in the domain of protection from adversarial AI? Is someone working on it? Are we going to see some solutions in the future?
Yes, so similarly to industry, most of our focus currently, at least, is on how to enhance cybersecurity with AI. We do some research in adversarial ML and cyber AI domains, but not in high volumes. Currently, most of our work is research-oriented. For example, our latest challenge was how to copy protect a model that was deployed on an edge or on an IoT device. And in that case, our research resulted with a proof of concept and eventually it was even assigned for patent. But in any case, I believe that very soon we will be asked to address these challenges more often, and the nature will be more production oriented.
Okay, thank you. And another question, if you can elaborate some more about how do you see the future of cyber AI? How is it going to be evolved? Where is it going to go? You know, how far is it going to reach? Is it going to be the main dish or?
So I think that it will be better for me to divide the answer to three parts according to the cyber AI vectors presented. So in the vector of adversarial ML on AI-powered systems, I believe that the protection methods will be very similar to those presented in previous slides. We should generate adversarial samples to create more robust models, and we also should monitor the different matrices that are related to the deployed model for fast response in the case a model should be retrained or changed somehow. Regarding the how to use AI for defend from AI for cyber offense, I believe that this is the most challenging vector, as the defender will always be reactive. He will not be able predicting what will be the attacker's usage with AI. So the defender's main challenge will be how to respond fast. And in the case of synthetic media, I believe that most of the focus, at least for now, will be on detecting what is the origin of the data and detecting whether it was produced maliciously using AI or not.
Thank you. I'm looking, I have here some more questions. I'm not sure we have the time for that. There is a question, one of them is, are you working on proactive botnet detection, especially in the social network bots and IoT area where we are all exposed, you know, for adversarial attacks and so forth? So if you can answer shortly.
So we are making some research in this domain. As I've mentioned, we are dealing with the API protection, web application firewall domains, and we do have some researches, but our main focus is not detecting whether it is a bot or not, at least now. It is more understanding whether we are undergoing a specific attack. For example, credential cracking or inventory stealing, or this specific attack, OWASP 10 attacks.